On to question 10 of the May 2018 AS Paper 1 Edexcel exam board. So we're looking at differentiation by first principles. Now, in terms of doing the actual question in the exam, you will just purely use algebraic techniques. I've got this little graph on the left-hand side just to teach you exactly what it means to differentiate by first principles and kind of why we do what we do. Okay, so bear with me on that. What I will try to do is stick to just writing what you would write in the exam on the right-hand side here. Okay, so in terms of describing this, I've plotted the graph of y equals x cubed and zoomed in a little bit on it. Okay, and I've just picked a point at random really. I've picked the point 1, 1, but I could have picked any point on the graph. Okay, so what I want you to kind of see is that when we're looking at a point on the graph, we get an x value and a y value, and then I've also picked another point on the graph. Okay, now what I've done in terms of plotting it, I just moved along just 0.1, a fairly small value. Okay, the principle really of differentiation, especially doing it by first principles, is that we're going to really make that change in x from 1 to some other number very, very small. Okay, and we'll talk about that a little bit more in a minute. On our diagram then, this is just some point. I'm just going to call it x now. Don't think of it really as 1. Okay, so when we put in an x value, this value over here is just going to be f of x or y. Okay, and then this next x coordinate, we're going to think of this as x plus a small number. Okay, in this particular example, it's exactly 0.1. I don't want you to think of it as 0.1, just think of it as a small number, and I'm going to call that small number h. Okay, really don't worry about what the h stands for. Okay, h is just a small number. Sometimes it's written as dx, and that's when you're doing your notation of dy dx, the dx means a small change in x. Okay, it's slightly easier to use the letter h when you're doing the algebra. So this value would be f of x plus h. Okay, now what we're basically going to do is find the gradient between these 2 points using what we would normally do at GCSE, just straight line graph stuff. Okay, so if you look at this little triangle here, it's going to be the change in y over the change in x. Okay, so if I write that notation wise here, okay, this and if I just blow this triangle up a little bit bigger so it's easy to write, okay, then this length here is h. If you think about the difference between what x and x plus h is, well, it is just this small number which we're choosing to call h. Okay, now the height of this triangle though, well, it's the two y values subtracted, so it's the higher value, which is f of x plus h, subtract f of x. Okay, and then gradients, okay, it's rise over run. You're going to do this rise over run. Okay, and I'm going to write that on the right hand side now because this is really what we're going to start actually writing out. This is just a brief explanation of it. Okay, so our particular function is f of x equals x cubed. Okay, so we're going to kind of use that as we're going along. This technique would work for any function. X squared is a good one to do when you're first doing it. Okay, so the gradient then. Okay, the gradient is, well, it's the change in y, which is f of x plus h. Okay, minus f of x, and then all divided by this small value h. And the principle behind calculus is that the smaller you make the value of h, the closer and closer and closer you get to the correct value for the gradient at that point. Okay, which is what we're trying to find here. Okay, that's what derivatives are, finding a gradient of that function at a particular point. Okay, so now we actually use the function that we're actually using in this question, which is x cubed. So the value of the y is going to be this cubed minus x cubed. Okay, and then all over this small change in x. Okay, so now we actually start doing the algebra. We need to actually expand x plus h cubed. Two ways to do that. You could just do it the long way, square it first and then multiply it by x plus h. If you use your binomial coefficients, okay, your binomial coefficients are 1, 3, 3 and 1 when you're doing a cubed bracket. Okay, and the first one is going to be x cubed, so it's 1x cubed plus, so then you go down, the x's go down, so this is going to have an x squared in it, this is going to have an x in it, and the last one's going to have no x's in it. Then you need to go up for the the other value, which in this case is h. So this is going to have a single h in it, this is going to have an h squared in it, and this is going to have an h cubed in it, and then I just need to squeeze some plus signs in between. So that's probably the quickest way to get the expansion for that. Okay, and then I mustn't forget to copy this bit down on the end. Okay, now what you can see here then is there's a couple of main things that are going on. Well, there's an x cubed here and an x cubed here. They disappear. If you did this with x squared, you'd get the same thing going on. Okay, and then the thing is all of these terms have h in them, so we can actually get rid of this fraction, and you end up with a function that hasn't got a fraction in it. Okay, and then as I say, there's the simple kind of principle here. I mean, it is a bit more complex than this really, but the simple principle here is that we're going to let h tend to 0. We're really taking the limit of this function as h tends to 0. Okay, don't worry if you haven't seen this notation. Some schools don't seem to go into it in enough depth really. Okay, but really you can effectively think that you're substituting h equals 0 into this, which means that these two terms here are going to just be 0 and you're left with this. And as you probably know, that is the derivative of x cubed.